A student investigated the effect of temperature. All right, we're going to plan a practical. This is going to be good. This is going to be useful. I'm going to show you how I do it. A student investigated the effect of temperature on the rate of start breakdown. Right. So we're investigating the effect of temperature on the rate of start breakdown by amylase. We've got a list of apparatus. Describe a method using that apparatus to investigate the effect of temperature on the rate of start breakdown. Okay. This is how I always do it well, not that I've done it, but this is how I always teach it. So whenever I do this, I always advise students to think about, before they even start, what is the independent variable? What is the dependent variable? What are the controlled variables? And then always remember repeats. So you could literally write that down. If you get asked to plan an investigation, before you even think about your method, just write down IV, DV, CV repeats. You could literally just write it like this. Yeah, IV, DV, CV repeats. Because if you get those, you're halfway there. So for example, independent variable, I'm going to be changing the temperature. Yeah. So I might write something like, use a range of temperatures. And I've probably already got a mark now, because I'm telling the examiner, I'm not just doing this at one temperature, I'm going to have to use a range of different temperatures, because that's what I'm changing. The dependent variable is the one that I'm measuring, and I'm measuring the rate of starch breakdown. Now, how am I going to do that? If I look at my equipment list, I've got iodine solution. So I'm going to be using iodine solution to measure the rate of starch breakdown by amylase. Good. So it's helping me to plan it, isn't it? Control variables, these are ones that I keep the same. And with any of these questions, if you want to get 5 or 6 marks, you need, I would say, at least 3 controlled variables. You need 3 to make sure you get 5 or 6 marks. So things like, for this one, you could go with volume of starch solution. You could go with volume of iodine solution. You could go with volume of amylase. Okay, don't worry if you need to go. You could also go for concentration of any of them. You could say concentration of amylase, concentration of starch, concentration of iodine, or volume. Initial temperature, no, you're going to be changing the temperature. So that's your independent variable. So you're going to be doing it at like 10, 20, 30, 40, 50, 60. So you're changing the temperature. So don't talk about temperature for a CV. But volumes of solutions, concentrations of solutions, try not to say amount. Volume and concentration is much, much better, because amount is not very sciencey. No, concentration and volume are separate points. You get 2 marks, Laurie. You could say concentration of iodine solution and volume of iodine solution. That would be 2 separate points. And then repeats, we always do at least 3. Okay. What about time? What, you mean like the time intervals? You could do that, couldn't you, as well? The time intervals between your samples. You could do pH as well. Yeah, you could control the pH, couldn't you? Because that affects enzyme action. So you could control the pH. Yeah, nice, 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 nice. But we've definitely got enough, because we've got at least 3, which is what we want. So then you're going to do a simple method. Keep it simple, structure it well. So I'm using the equipment. So I'm going to mix, what have I got? I've got amylase and starch solution in a test tube. I'm using their apparatus that they've given me. I'm going to put in a water bath at, suggest any temperature, doesn't matter. Because at the end, you can just say repeat at different temperatures. So it doesn't matter. As long as you've got the idea of different temperatures, they don't care. Don't overcomplicate it. But obviously you're going to mix your enzyme with your starch in a test tube, put it in a water bath at your first temperature. And then you're going to take a sample after, what do you want to do? It doesn't matter what you suggest. You could say, take a sample after 30 seconds. and drop into iodine. And then repeat until iodine stays orange. Right, just check you're understanding this. Why am I going to keep taking samples until my iodine stays orange? Sammy, control variables, yes, super important. Yeah, the iodine is in a spotting tile. So you've got your spotting tile. I'll do you a little drawing. So you've got your spotting tile like this, and you're putting like drops of iodine. So I could include that information. It's not totally necessary. Drop into iodine on spotting tile. Right, it shows that all the starch has been broken down, because think about it. My first sample that I take, I'm going to put it into the iodine. It's going to go black because there's still going to be starch. Then I repeat it again after 30 seconds. It's probably still going to go black. There's probably still going to be starch. But I'm going to repeat until the iodine stays orange and record the time taken. Because when the iodine stays orange, there's no starch left. So this shows all starch has been broken down. Okay? That's it. That's so easy to do. Don't overcomplicate your methods. They're not bothered about volumes. You know, take 10 centimeters cubed of this and 10 centimeters cubed of this and put it in a boiling tube. Like, they're not really bothered. They just want a basic outline. They're more bothered about, have you done your control variables? Are you going to do this at different temperatures? And are you going to say that you're going to repeat it? So let's just finish this off, okay? And let's check we understand it. We've mixed the enzyme with the starch in a test tube. We've put it into a water bath at the first temperature. I've just gone for 20. We're going to take samples with a pipette. You don't have to say that. After 30 seconds, and drop it onto some iodine that we've put in a spotting tile. And you're going to repeat this until the iodine stays orange, because that is going to tell you all the starch has been digested. There's no starch left. Record the time taken. And then we can just say repeat at other temperatures. And if you want to, you could suggest some. And then it's always good to say repeat 3 times at each temperature, and calculate. What am I going to finish that off by saying? If I do this 3 times at each temperature, what does that mean I can do? Which is always good to include in a method. You preempted my question. Well done, Glenua. Yes, repeat 3 times at each temperature and calculate a mean time taken. So I'm recording the time taken for the iodine to stay orange, because that tells me all the starch is gone, right? Now, the way the examiner is going to mark this, they're not bothered about all the intricacies. They're going to look at it and they're going to think, have they done it at different temperatures? Well, yes. Have they got a basic method that I can follow? Well, yes. Have they highlighted command variables? Now, I did it literally right at the start, at the top of my answer. I said what the control variables were, and then have they got repeats? So that's how I would recommend structuring it. Start off by just thinking, what's my IV, what's my DV, what's my CV? Remember to repeat. Basic method, but remember to repeat it at the end, because then you can calculate a mean, check you've got at least 3 control variables, and check it's logical. Okay. A control variable, not a command variable. Millie, I always write the variables at the top, because then it helps me figure out how to plan my method. But the ones that are most important that you must write are the controlled variables. If you just did the first part, Sienna, you mean you didn't actually write a method? If you literally just listed your variables, you could probably still get 2. You could write it out exactly like this, yeah. You don't have to give examples of other temperatures, Audrey. You don't have to. You could just say repeat it at other temperatures, plural, because then the examiner will give you credit because they know you're doing it at different temperatures. Yeah, banana. This is how I would lay it out, exactly how I would lay it out. And it makes it easy for the examiner to mark because they can clearly see straight away, this is a good student. They've got at least 3 control variables and they're going to talk about repeats. That immediately is going to make them think this is a student that can get 5 or 6 marks, because right at the top, you've reminded them of repeats and you've listed at least 3 control variables. Then all they have to do is check that your method makes sense and that you've done it at different temperatures and it would work. And then you've got all the marks, you've got 6 marks. The variables I include at the top of my answer, Tayeb. That's just how I always teach, like planning a practical. Such good practice to do it like this. IV, DV, CV, repeats. The CVs are so many students write a perfect method, but nowhere do they put any control variables. And then they quite often end up getting only 2 marks. Okay. Steps 4 and 5. So you're going to take a drop out of your enzyme starch solution and pop it into iodine. If there is still starch left, it will go black, right? Blue-black. But we're trying to find out how long it takes for the enzyme to digest starch. And when all the starch has been digested, it won't go blue-black. The iodine solution will stay orange. So we're recording the time it takes for the iodine solution to stay orange or not turn blue-black anymore. That makes sense. Okay.